So today we're gonna learn about subtracting vectors, and before subtracting vectors, you want to make sure that you know how to add vectors and also multiply vectors by scalar. And you also want to know what a vector is. If you don't know any of these, go back to my channel, there are videos about this. So assuming you know this, then let's begin. So let's just come up with a vector, and let's call this vector here, so vector A. That's just the simplest name for it. Okay, so great, we have vector A. I want vector B. So if I know that if I add the two vectors, I get a new vector. What if I subtracted the two vectors? So vector A subtracts vector B. So vector B is taken away from vector A. What do I get? So firstly, what do I get? Like, what type of what type of answer do I get? Is it a scalar? Is it a vector? Is it even a number? Well, the answer is yes, it is a vector. Just like addition. So this is just like addition because we know that. So why is this the same as addition? So we add two vectors, you get a new vector. Subtract two vectors by each other, you get a new vector. Because essentially this is just vector A plus negative vector B, right? You can just think of this. You can just think of the expression above as this. So we know that if you multiply, so if you have negative vector B, it's just essentially multiplying vector B by -1. -1 is a scalar, so a scalar multiplied by a vector produces a vector. So this thing here is a vector. So the sum of two vectors is going to be a new vector. So that point is valid. Okay, so now moving on to my second point. Right now, what we're going to do here is we're going to illustrate the fact that, so we're going to use an example to illustrate the fact that vector A minus vector B is actually, so vector A minus vector B is actually equal to negative vector B minus vector A. Okay, so how do we prove this? I mean, it's obviously just so simple to prove it, right? I mean, if we expand the brackets, it's just vector A minus vector B. Like, it just mathematically makes sense. So what about on the logical side? How do we make sense that, firstly, that's the difference between two vectors is a new vector? And also, how do we actually just subtract two vectors without having to do this thing every single time? So let's say my vector A was 2, 3. Vector B was, let's say 3, 4. Nah, actually 4, 5. So if I subtract, so firstly I'll just draw the two vectors out. So I'll draw 2, 3, so my vector would be something like this. Yes? So now I have vector A and I want vector B. So what's vector B? It's 4, 5. So 1, 2, 3, 4. 1, 2, 3, 4, 5. I know this is not drawn to scale, but just imagine. Imagination is important in math, so yeah. Okay, so this is gonna be something like that. Okay, so we have two vectors now. We have vector A, vector B. We wanna subtract vector B from vector A. So how do we do this? So basically, we know that we have to add the opposite. So we have to add negative vector B to vector A. So what's negative vector B? So negative vector B is actually just -4, -5. So we have 1, 2, 3, 4, -4. 1, 2, 3, 4, 5, -5. Okay, so if I took the opposite of my vector, then this is what I'd get. Now I want to take away A from B, so basically I have vector A plus negative vector B. So what do we do when we add two vectors? we copy one vector and we copy one vector and we paste it so that it collides head to tail with the other vector. So how does this exactly work? So when we add two vectors, basically we want the head of one vector to so that the side of an arrow to collide with the tail of one vector, the side of that's an arrow. Now the resulting vector is going to be this red one over here, or this green one actually, because why not? Okay, so the resulting vector is actually, the tail of the resulting vector is the starting point of the yellow vector. The head is the ending point of the blue vector. So this is our green vector. That's actually just the sum of the blue and yellow vector. Or actually that's just vector A minus vector B. So that's just vector A minus vector B, which is vector A plus negative vector B. So I hope that makes sense. So now let's just try to see what vector B minus vector A is. Okay, so vector B stays the same. Vector A, however, as we see above, so this is going to be equal to vector B plus negative vector A. Okay, so negative vector A is actually just, so you have 1, 2, so negative 2, 1, 2, 3, so negative 3. So that's negative vector A, or approximately negative vector A. So that's our negative vector A, and we wanted to add, so if that's negative vector A, we wanted to add negative vector A and also vector B together. So let me just draw this more realistic looking. So something like that. Then basically what we do here is we copy and paste the blue vector, and basically now what we do is we put the head of the blue vector so we put the tail of the blue vector to the head of the yellow vector, and we put so our resulting vector is gonna be a red vector which starts from the origin and ends at the ending point of the blue vector. So this is this vector. Now I know this isn't accurate enough, however, if we actually do the math, like if we actually add the two vectors together, we figure out that this one over here is gonna be, so this over here is gonna be equal to, so vector A minus vector B is gonna be negative 2, negative 2. Now vector B minus vector A is gonna be equal to 2, 2. So how did I do the math? So basically I took negative 1 and I multiplied it by the vector I had to. So here I multiplied B by negative 1. Here I multiplied A by negative 1. And then I just did simple addition of the components, because that's just addition of vectors now, after we simplify this part into a simple vector. And then we learned about addition of vectors. We didn't then just watch my videos, but we did, so the resulting vectors will be negative 2, negative 2, and 2, 2. The graph isn't accurate, but mathematical proof states that the two operations, the two expressions are indeed opposites of each other. Now this is not just a simple proof of why the green vector is an opposite of the red vector, because we can just simply prove that mathematically, as I have done at the start of this lesson. However, the most important part is that this example tells us how to subtract vectors. So in fact, if I had two vectors now, then basically if I want to subtract vector B from vector A, what I do here is I take the x components and I subtract 4 from 2, so I do 2 minus 4, so my answer will be like this, so 2 minus 4 and 3 minus 5. So that's actually how we can get negative 2, negative 2. So why is that? Because we're actually just adding a negative yellow vector or negative vector b. When we add negative vector b, we result in adding negative 4, negative 5. So if we have 2, 3, and we add that to negative 4, negative 5, isn't that the same as 2 minus 4? So isn't that the same as the vector 2 minus 4, 3 minus 5? So that's just the same logic, but it's simplified a lot. So thanks for watching.